denoted by probability of B given A. That is the meaning of this. This means probability of B given A. Okay? Now, is defined as the probability of B given A equals to the probability of A intersection B over the probability of A, provided that probability of A is greater than 0. So, this is the formula for conditional probability. Now, two events A and B are independent if and only if the conditional probability of B given A is equal to the probability of B, or the conditional probability of A given B is equal to the probability of A. That is, two events A and B are independent if and only if the conditional probability of B given A is equal to the probability of B, or the conditional probability of A given B is equal to the conditional probability of A. Now, what we have done here is the conditional probability of B given A. What is the formula for conditional probability of A given B? Can anyone deduce for me? Can anyone tell me the formula? This is the formula for conditional probability of B given A. What will be the conditional probability of A given B? Given A is equals to the probability of A intersection B divided by probability of A. Okay? Now this is B given A. Now what is the conditional probability of A given B?
The probability of A and B
A intersection B
over B.
Probability of A. It's going to be the conditional probability of A given B will be the probability of B intersection A divided by probability of B. Do you understand? Good. Now I'm going to give you a theorem. Now, before the theorem, two events A and B are independent. That is, they don't depend on each other. If and only if the conditional probability of B given A is equal to probability of B, or the conditional probability of A given B is equal to probability of A. Now I'm going to give you a theorem. Now, if these two conditions did not hold, that means the probabilities are dependent on each other. So I'm going to write otherwise A and B are dependent. That is, event A and B are dependent if this condition did not hold. So theorem. Two events A and B are independent if and only if probability of A intersection B is equal to probability of A multiplied by probability of B. Now this is a theorem to clarify what we've been talking about. Two events are independent if and only if probability of A intersection probability of B is equal to probability of A multiplied by probability of B. So I'm going to give you the next 2 minutes for you to write down, then we'll look at an example. Thank you. An accident. To solve this question, the first step is to look for the probability of white car and red car that had an accident. Now, we're told from that question that only 4% of all these cars had an accident. So, for us to get the probability of the black car, okay, in a city, cars are colored black, white, or red. 10% of all cars are black. So, black cars that was involved in accident. Is 0.04 multiplied by 0.1. Am I right? How do we come across those figures?
Divide by 100.
You divide by 100. So 10 divided by 100 is what? 8. So can you give me the multiplication of that? Can you punch your calculator and tell me what is 0.04 multiplied by 0.01 will be? Everyone should bring out your calculator. Cars are colored black, white, or red. You see now. Are black, 60% are white, the rest are red. In the past 1 year, 4% of all cars had an accident. 15% of that 4% of all cars that had an accident is black. 45% of all cars that had an accident is white. The rest are red. Now, we have to solve them step by step. In a city, cars are colored black, white, or red. 10% of all cars are black. 60% are white. The rest are red. So, how many percent is red car?
30.
Red cars are 30% in that city. Okay? The solution starts from here. Okay. Now, that is settled. In the past 1 year, 4% of all cars had an accident. 15% of all cars that had an accident are black. So we are going to have 0.04 multiplied by 0.15. Am I right? Check it for me and tell me what the answer will be. 0.15. So we have 0.006. These are the percentage or the numbers of cars, the probability of cars that are black car. Am I right? 4% of all cars had an accident. 50% of that car that had an accident are black. So this is for black cars. Now we do similar thing for the next one, which is 45% are white. So we have 0.04 multiplied by 0.45. And that will give us what? Can you punch the calculator and tell me your values? 0.018. This is for white cars. So we are to determine that of red car now. If we have 15% for black, 45% for white, that is how many? 60%. So the remaining 40% would be for what?
Red cars.
For red cars. So we have 0 multiplied 0.4 multiplied by 40% 0.4, which will give us what? 0.016. These are for red cars. Now we can draw our table for the conditional probability. Our tables for the conditional probability. So we can draw this way. We have the first column for black cars. the second column for white cars, and the last column for red cars. Also, on our left, we have cars that are involved in accidents. And the next row will be for cars that are not involved in accidents. So I will take that as non-accident. So for the black cars, we have 0.006. For the white cars, we have 0.018. And for the red car, we have 0.016. To calculate those ones that are not involved in an accident. So, for the first part, we have 10% of all cars are black. 10% of all cars are black. 10% of all cars are black. So, in order for us to get the amounts or the probability for those that are not involved in an accident, we subtract those ones that are involved, the probability of those ones that are involved in an accident from the total number of black cars. Okay, so to get the number of black cars that are not involved in accidents, we have 0.1 subtracted from 0.006, and that will give us what? Can you punch your calculator and tell me? For black cars that are not involved in an accident, the probability is 0.094. Black cars not involved in accidents. Okay? Now, what about white cars not involved in accidents? We are going to have, given 60% are white cars, so it's going to be 0 multiplied 6 and 0.6 subtracted from 0.018. Can you punch your calculators and tell me what your answer is?
0.582.
Is 0.582. So here we have 0.582. And finally, don't forget we calculated for red cars here in that city. So this will give us red cars not involved in accidents. 0.3 subtracted, we subtract 0.016 from it. And what will be our answer?
0.284.
0.284. So I'm going to give you some minutes to write down the tables. Given that a car is red, what is the probability that the car has an accident? Given that a car is red, what is the probability that the car has an accident? So we are going to make use of this formula. Given that a car is red, what is the probability that it has an accident? So don't forget, this is the probability of A given B. Okay? Probability of the car has an accident. Probability of B. Probability of accidents given that it is red, is equals to, we are using this formula. So who can tell me what the formula will be using this? It's going to be probability of R intersection accidents over probability of R. Now, probability of R intersection accident is here because this is R that stands for red car and this is the row for accident. So this is the intersection of both cars. So we are going to have it here equals to 0 multiply 0.16 divided by the whole probability of R. This is everything. This is all the probability of R. So we are going to have 0.016 plus 0.284. Can you tell me what your answer will be? 0.3. No, are you sure?
0.016 plus 0.284. 0.2.
No, it's not 0.3. Try it again.
0.016.
0.53. Yes. Probability is 0.053. So this is the conditional probability. The conditional probability, given that a car is red, what the conditional probability is 0.053. Conditional probability of B given A. Conditional probability of A given B. Independent or dependent. What is the probability of accident given red? It is 0.05. What is the probability of accident itself from the question? It is 0.04. Are they equal?
No, sir.
So what are they?
They are independent. Sir, dependent.
They are dependent.
Dependent.
So
Dependent.
please put down your answer. The events are dependent. Why? Because probability of accident is equals to 0.04 and probability of accident given red cars is equals to 0.053. They are not equal. So they are dependent events. 70% in a class studied hard. The rest don't. For students studying hard, the probability of passing the course is 85%. For others, 25%. Given that a student has passed the course, what is the probability that he or she studied hard. So let's look at the solution of this example. 70% of the students in a class studied hard. So number of probability of students that studied hard is 0.7. Am I right?
Yes.
Now, the rest don't. So, probability of students that did not is 0.3. Am I right?
Yes, sir.
Now, we were told from the question that for students that studied hard, the probability of passing the course is 85%. Probability of passing for students who studied, for students that studied hard is 0.85. And for others, probability of passing for students that did not is 0.25. Given
Sorry, 1.5.
how 1.5? How is 1.5?
Okay, sir. I didn't look at it. Sorry.
Given that a student has passed the course, what is the probability that he or she studied hard? So we are looking for the probability that the student studied hard, given that he or she has passed the course. So the probability for students that studied hard, is this. Probability for students that did not is this. Probability of passing for students that studied hard is this. Now, probability of students that studied hard and they passed. Probability of students that studied hard and they passed. Is 0.7 multiplied by 0.85. What is that? Can somebody tell me? Okay, please. Student passing or studying hard. Probability is 0.7 multiply 0.85, which is what?
0.595.
595. Now, students passing, even when they did not study hard, probability is 0.3 multiply 0.25. And what is this?
0.075.
0.075. Okay. Now, probability that students who studied hard, they still failed. Okay. Is going to be students failed even after studying hard. Probability is 0.7 minus 0.595, and this is what? (0.105). Now, student failed for not studying add. Probability is 0.3 subtract 0.75, which is what?
0.225.
0.225. 0.225. So we can now draw our table because all the information to draw our table is completed. So we have our table this way for study and for those that did not study. Now here for passing and for failed. Okay, let me just say pass and fail. Here we have 0.595. Here we have 0.105. Here we have 0.075. Here we have 0.225. Okay? Now this is our table. Now, probability for studying and passing, which is the question. Given that a student had passed the course, what is the probability that he or she studied hard? So, probability of studying hard, given that the student passed. Probability of study, given that the student passed, is equals to probability of S intersection P over probability of S. Am I right? Can you take me back to the formula? What's the formula? Probability of B. So here we are going to have intersection of study and pass. This is the intersection of study and pass. Pass, study. Okay? So here we have 0.595. And for passing, we have 0.595 plus 0.075. So what will be our answer?
(0.888).
0.888. We can approximate it to 0.89. Okay? So that is the solution for their preference. Of breverages. 33 students prefer cola zero. The rest preferred normal cola. 55 students prefer coffee without sugar. The rest prefer coffee with sugar. 27 students prefer both cola zero and coffee without sugar. Given that a person prefers coffee with sugar, let this marker rest this highlight. So I give you the definition of random variable. Definition: random variable. A random variable is a function that associates a real number with each element in the sample space. In the previous class, I've given you the definition for a sample space. Random variable can be described as discrete or continuous. So random variable can either be discrete or continuous. Example: there are 10 balls in a box. 4 of them are black. 6 are white. We draw 2 balls without replacement. The number of black balls is a random variable. So, in this example, the random variable here is discrete. So, I'm going to write in front discrete. Good. Similarly, I'm going to give you an example of a continuous random variable, after which I will give you the definition of discrete probability distribution. So another example for continuous random variable. Example: the thing between passing of two trucks along the way is a random variable, and this is continuous. So these are examples of continuous and discrete random variable. So I'm going to give you some time to write that down before we distribution. Okay. Now, if f of x is a function, is a probability function, or probability distribution of the discrete random variable x. If f of x is greater than or equals to 0, if the summation f of x across x is equals to 1, and the probability of x equals to f of x. So that is the definition for discrete probability distribution. Now we are going to give, we'll go a bit further to give the cumulative distribution function. Cumulative distribution function. Let the discrete random variable x have the probability distribution f of x. The cumulative distribution function f of x is defined as f of x equals to probability of x less than or equals to x is equals to summation t less than or equals to x of t. So this is the cumulative. Let's take the definition for continuous probability distribution. Continuous probability distribution. F of x is a probability function of the continuous random variable x if f of x is greater than 0, the integral from minus infinity to infinity f of x is equals to 1, and the probability x a less than x less than b is equals to the integral a to b f of x dx. Now I will give the cumulative distribution function. The cumulative distribution function f of x of a continuous random variable x with density function f of x is f of x equals to p x less than infinity to infinity f of t. Let's see. Therefore, the probability from a less than x to b is equal to f of b minus f of a. Determine C such that f of x is equal to c x squared plus 4 for x equals to 0, 1, 2, 3 is a probability distribution. So now, what is this question asking us to do? This question is asking us to determine the value of C. That's all. Given this probability function, this is the probability function. This f of x, this is it, is the probability function. Are you getting me? Now, given this probability function, we have to determine the value of C. And don't forget, this is a discrete probability distribution. It's a discrete probability distribution question. Okay? Now, we are going to follow all these things in order to get the value of C. Now, you will agree with me that f of x is greater than 0. This is f of x. It is starting from a 0. If you plug a 0 here, what you will have is 4c. 4c is greater than 0. Okay? The only condition whereby 4c can be 0 is when c is 0. Are you getting me? Yes. But c is not, we don't know the value of c we want to determine. Okay? Now, secondly, when you sum everything across x, that is what we have here for a fixed value of x, all these values of x. When we sum everything, we must get 1. Are you getting me? That is the meaning of this. We must get 1. And lastly, the probability of x must be equal to the probability density function. Do you understand? So that's the meaning of this. Now, let's look at it. We have when x is equals to 0, we have f of 0 to be equals to c into 0 squared plus 4, which is equals to 4c. Am I right?
Yes, sir.
When x is equals to 1, we have f of 1 to be equals to c into 1 squared plus 4 equals to what? 5c. Am I right? Similarly, we continue for other values. When x is equals to 2, f of 2 will be equals to c into 2 squared plus 4, which is equals to 8c. And when f is equals to 3, we have c into 3 squared plus 4, which is equals to 13c. Now, using this summation, x, f of x must be equals to 1. It implies that 4c plus 5c plus 8c plus 13c equals to 1. Because when you sum everything together, it must be equals to 1 according to this. Okay? Now, 4c plus 5c will give you 9c. 9c plus 8c will give you 17c. 17c plus 13c will give you 30c. Am I right?
Yes, sir.
So you are going to have 30c. C to be equals to 1. So C is equals to 1 over 30. So which is the value of C that the question is asking us to look for? So you will agree with me, 1 over 30 is greater than or equals to 0. Summation of everything, if C is 1 over 30, if you plug in C, everything will be equals to 1. And if you take the probability of X, it will give you this f of X. Okay? So, is it not simple? It is simple. Well, in an experiment, be given by f of x equals to x squared over 3 is 0 elsewhere, and x squared over 3 in the interval minus 1 less than x less than 2. So when you see probability function of this form, you know it is a continuous random variable because we are having this interval minus 1 less than x, x less than 2. So it's a continuous random variable, which is quite different to this discrete random variable. There is no interval involved in this, okay? So when you see questions, you should be able to determine whether it is a random variable, continuous random variable, or discrete random variable, depending on the question and depending on your knowledge of definition of continuous random variable and discrete random variable. In the definition for continuous random variable, you can see we have intervals. Yes. But in discrete, there is no intervals. So all those things you put into cognizance. So now, how do we solve this? Let the error in an experiment be given by this. Okay, the question is incomplete. A. Verify that f of x is a density function. Okay. B. Find the probability 0 less than s, s less than or equals to 1. So we are asked to find this probability. Now we are to verify whether this is a density function. You will agree with me that over this interval, f of x is equals to x squared over 3, isn't it? Over this interval is equals to what?
X over 3.
Is this greater than 0 or not greater than 0? For any value of x that you can imagine, which is not a negative value for x, is it greater than 0? It will always be greater than 0.
So here is s is equal to here is equal to 1.
Is a mistake. So it satisfies this first condition. If you take f elsewhere to be 0, is equals to 0. The only reason why this will not be equals to 0 or greater than 0 is if x assume, in fact, for every value of x, whether negative or positive, this will always be greater than 0. So this first condition is satisfied. Okay?
Yeah.
Now, if you take the integration of this function, s squared over 3 from minus 1 to 2, the x, you are going to have 1 over 3 minus 1 to 2 x squared the x. I want to believe in this class we can take this integration because we've done it in calculus 1. So you are going to have 1 over 3 x cubed over 3 from minus 1 to 2. This will give you 1 over 3 into 8 over 3 minus, it becomes plus 1 over 3. And this becomes 1 over 3 multiplied by 9 over 3. This cancels this, we have 3. 3 divided by 3, we have 1. This condition is satisfied. That these ones are greater than or equals to 0, and the other one, it is very obvious. Okay? And this one is just a mere definition, and it is obvious. But if you can take from any interval within minus infinity to infinity, and you can establish it to be 1, like we did in this case, then it's enough for you to conclude that it is a density function. Now, in the exam, you don't leave your solution like this. After solving and you arrive at 1, you are going to follow it up with a statement that since the conditions are fulfilled, since the conditions for density function are fulfilled, then f of x is a density function. Simple. So we are done with the A part of the problem. And similarly, if you look very well, we are done with the B part of the problem. The B part of the problem is just a repetition of what we have done when we are trying to verify. Probability 0 less than x, s less than or equals to 1 is equals to, I think it's minus 1, or am I sure? Okay, this one is different. This one is from 1 to, from 0 to 1. We have x squared over 3 dx, which is equals to 1 over 3, 0 to 1, x squared dx. Now we have 1 over 3, x cubed over 3 from 0 to 1. Here we have 1 over 3 multiply 1 over 3, which is equals to 1 over 9. So the probability within this interval 0 to 1 is given as 1 over 9. Good. So